Okay, so first thing, now I'm recording. So now you can type your name for the attendance in the chat. Anything you type before is not recorded. So if you type now, then we'll have your name for the attendance. So yes, it's been 8 months. I had a baby during that time. So I have little Hannah. So she's 6 months old now, and I have my Tali, who's 3 years old. But I've missed teaching this class, and so I'm glad to be starting the semester up again. I think we're usually going to have a lot of people. I think that there's about 40 or 45 teachers who are signed up. So usually we'll have more, but today everything is going a little bit slowly because the data was distributed slowly. I'm just going to post the link to the Zoom room one more time in the chat, just because some people are still asking how to get to it. So let me just type this in: zoom.us/j/882.0889. Okay. Passcode 3.1459. Okay, so hopefully people will join in. So yeah, I hope everybody had a good spring and a good summer, and we're looking forward to having a great training session for this year. So and hopefully the data will get distributed earlier for our next session, so that we won't have this delay process. So most people here, I think I recognize your names. I'm trying to think. Every single person here, I think, was in the class last year. I saw a couple of new names, but they're no longer in the room. So I have a whole introduction planned, but I think you all know me already. There should be some new teachers coming in at some point today. But maybe I'll for now I'll skip my introduction of myself, because you all know me. And maybe I'll do it later on in the class if some more people join who are new to the training this semester. So let me just skip these little bits about the introduction of me and start talking about how the semester is going to work and what are kind of the new things. So the topics for this semester are going to be: the first half is going to be about statistics. Seems like there's been a lot of demand for some work on statistics. And then the second half is going to be plane geometry. So we talked about trigonometry a couple of times ago, and we talked about vectors last year. But we're going to be spending a little more time this year doing very specific stuff about plane geometry: circles and triangles and parallel lines and perpendicular lines and relationships between them, and areas and perimeters and volumes and not really volumes, areas and perimeters, and all of these things about plane geometry, Euclidean geometry. So I solicited a lot of feedback after the training last year, and a lot of people responded, which was good. And the most frequent comment that I got was that many people want the lessons to be closer to what is in the Liberian high school curriculum. So I'm taking that to heart this semester, and I'm going to try to make sure that everything is tied in with something specific that's in the 10 to 12 math curriculum for Liberia, which Sange sent to me, and which I think has been passed around the list a little bit over the last few days. So what that does mean is this material is probably going to be a little bit more basic than what we've studied in the last 2 years. So the stuff we were doing in the last 2 years was kind of a mix of high school and some more university level stuff, with especially with the vectors and the linear algebra and everything like that. So this is going to be more on kind of basic statistics and plane geometry, at least for this semester. So I haven't yet decided what we're going to do in the spring. So one possibility is that we continue with statistics and do some of what's called inferential or bivariate statistics, which goes a little bit beyond the high school curriculum. Or we could do a totally different topic. So that will depend on the feedback that I get. So maybe the biggest change is that we now have a website, which I think is going to be much better than having to find all of these links by scrolling in the WhatsApp chat. So this is the website address. I don't really expect you to remember this, but instead, what's a little bit easier is if you just open a web browser And if you just Google, you just go to google.com or type something into a search bar. And if you just Google Andrew Obis Liberia, then you'll get the first link is going to be the website. So you don't really need to remember, just Google Andrew Obis Liberia. And right now the website doesn't have very much on it. It just has, it has the room. It doesn't have the passcode because I don't want to put that on the internet for anybody, but you can always find the passcode, and it has the schedule. And right now it has the syllabus, which maybe I'll click on in a little bit. And then it also has this YouTube page, which is going to have the recordings of all of the lectures. So right now, if you click on the YouTube page, there's some stuff from last year. Okay, I started to post recordings of last year's thing, January 20th, January 13th, January 6th, December 16th. So these are the full recordings of the class, and all of the classes from this year will be posted on this page, so you can watch them on YouTube. Okay, let me move back to, no, that's not what I want. Okay, let me go back here. And what I want to do is start page, back. There we go. How do I close this? There we are. Okay. So, and then there's going to be the lecture notes over here. There's going to be the lecture notes from each of the lectures. There aren't any lecture notes yet because this is the first lecture, but I'm going to post them all right here from the website. So they're all collected in one place and you can see them. Okay. And then we also have the syllabus, which maybe a lot of this is basically the same as it's been in the previous semesters. So we have our meeting time, which is usually at 4:30, but today is going to be at 3:30. The Zoom link is the same link that we've always had, ever since the Zoom link is the same link we've always had, and the password is the same as the password's always been. This is just another link to the website over here, and another link to the website on YouTube, where I have my YouTube channel where we post all the videos. Everybody here is in the WhatsApp chat room, so that's fine. I will send some textbook resources later on. We're not going to be following a textbook, but there are some statistics textbooks that I'll write about later on. The objective is kind of always the same, that there's a meta objective, a big objective for everything that we do, which is to improve our skills in problem solving in mathematics. And that means not only being able to solve a set kind of problem that you've seen before, but being able to use your skill to solve a problem that doesn't necessarily look like something that you've seen before, but is something that you can still do based on your knowledge, based on what you have. And each time we pick different topics. And so here we're using statistics and plane geometry as our main topics. Homework, as usual, there's going to be homework every week, except this week. This week, there's no homework. But starting next week, there will be some exercises assigned at the end of every session. And we'll usually spend our time going over the exercises. And you should do them. That's how you'll be prepared for the next session. And if you want to send them in writing to me, that's fine. And I'll look over them and I can tell you if you've made a mistake or if you've done it correctly. And in any case, you should occasionally volunteer to present the problems in class. Okay, so homework. So that's the homework. One other thing that's new is that there's going to be a project that's not going to happen until January, but because we're doing statistics and statistics is all about data and working with data and presenting data, there's going to be a data collection project that will probably have 3-4 weeks to do. And what I'd like to do is maybe have a session where people can, present, their projects online. I don't know how practical that will be. It depends on whether the data and the network will permit that. And if that's hard to do, then maybe it can even be an in-person session in Liberia, where everybody does that. And I can maybe somehow zoom into the session where everybody's in a room doing their data presentation. But in any case, that won't be until January. So we'll have a little bit of time to work on that. And then the attendance policy, especially for this year, because there are so many people who are signed up to receive data, we're definitely at our limit on participants. So the participants are expected to attend the classes consistently. If you miss sessions, then it's very hard to catch up. And if you miss more than 3 sessions without some very good reason, then you may be dropped from receiving data funds further on. I mean, everybody's always welcome to come to the sessions, but we can't keep sending data funds to people who miss 3 weeks in a row. We don't have enough data for that. Okay. So the big changes are that I have this website now, and that there will be this project a little while down the road. Okay, so let me go back to here. Right, so I'm going to post the lecture notes and video recordings on the website, and as I said before, if you forget the web address, all that you have to do is put Andrew Obis Liberia into Google, and you'll get it as your first or second match. Okay, so and it won't be hard to find. Okay, so right, so I mentioned this already. This is everything about the homework problems, and this is also in January. There's going to be a break for a couple of weeks. One last thing with the syllabus. There's also a schedule on the syllabus. So this has the tentative list of topics that we want to do. So today we're just going to be talking about an introduction to statistics. What is it about? Why is it important? Next week, there's no class. There's a Jewish holiday that day, so I'm not going to be there. And then we'll have class, almost every week. But the schedule, which is on the syllabus, which is on the website, tells for every day what we're going to cover, if there's class, and then there's going to be one other day, October 13th, where we're going to meet 1 hour earlier at 3:30 instead of at 4:30. And right now, this has us go on to January 6th, but we're going to keep going after that. We're probably just going to take a 2-week break around then for people to do their projects, and then we're going to resume with some more geometry and then whatever more advanced topic we want to work with in the spring. Okay. So any questions about the syllabus or about how things will run? I mean, most people are familiar with how things work from last year.
For me, I don't have a question.
No.
But
Okay.
I just want to say congratulations to you on your new child.
All right. Thank you very much. Yeah, I'll have to find some pictures to show, but thank you very much. Yeah, it's very it's been great. All right. Anything else? Okay, and so the important thing to remember is that next week there's no class. So the next time we're going to meet is 2 weeks from now on September 22nd. Okay, but we'll remind everybody in the chat. Okay. Okay, so let's get back here. Okay, so let's talk a little bit about statistics. Okay, and I'm going to warn you that my training is in mathematics. My training is not really in statistics, but of course, statistics and mathematics are very related, and statistics is part of the mathematics curriculum in Liberia, right? It's taught in math classes. So, what is statistics? So it's the study of analyzing, interpreting, displaying, and making inferences from data, right? You're not doing statistics unless you have data. So if somebody asks you, okay, here's, 6 numbers, find their average. Well, that might be a kind of statistics problem that you might see on an exam, but that's not really statistics, because if somebody's just giving you numbers and you don't know what the numbers mean, then you're not really doing statistics. Okay, so statistics, the numbers are always coming from somewhere. They mean something. There's a reason you want to take an average or compute a standard deviation or do any of these types of things that you have in statistics. It's because the numbers that you have actually signify something. And depending on what they signify, you might want to do something different with them. It doesn't always make sense to take the average, or it doesn't always make sense to take a minimum or a maximum. It depends on what your numbers actually mean. So statistics, right, is built on mathematics and probability, but it's not the same thing as mathematics and probability. And in particular, with statistics, there isn't a lot of times you're trying to answer questions where it's not clear that there's one right answer. It's not clear there's one way to do it, right? So if I ask you a math question, usually there is a correct answer. But a statistics question might be like, okay, we have some data here that's drawn from a population. How much can we learn about the population from this data, right? And so that's a question that people can argue, is the data good? Is it accurate? Is it something that we're going to be able to learn a lot about? Is it something that we're not going to be able to derive very much from? So statistics, especially when you get into advanced statistics, does not always have, one clear answer. Now, of course, for the statistics, that's part of the math curriculum. That's the more mathematical side of it. And for a question on WAS that covers statistics, of course, it's going to have a right answer. Right. I mean, these things have to be phrased so that there is a right answer. But I want you to keep sight of the fact that statistics is somehow, it's a much less exact field of study than math. Okay. Judgment comes into statistics. There's not necessarily a right way to do statistics or a wrong way. There's possibly, there's certainly wrong ways, but there are different things that can be right. Okay. And it's not as rigid as math. Okay. So for this training, we're going to focus on, the part of statistics that's emphasized in the Liberian curriculum, which is descriptive statistics. Okay, so descriptive statistics means what? It means somebody gives you some data, which is usually, not always, usually it's going to be a bunch of numbers that mean something. So it could be test scores, it could be, income levels of countries, it could be, goals scored by a player in a bunch of different football games, right? It could be anything, but usually it will be a bunch of numbers. And we have various mathematical things that we can do with these numbers that help us describe them in a more useful way, okay? Now, of course, statistics is not always just about numbers, right? I mean, you can take a poll of you can ask a bunch of people what political party they belong to. And then the data that you're getting is these political parties. It's not necessarily numbers. So different, and the numbers could be, instead of numbers, it could be, your data could consist of locations, like you want to understand where there's a valuable metal to be mined, and you have certain measurements in different parts of the earth, detecting this metal, right? And so there your data is going to be locations. So data can come in lots of different forms, but usually it's going to be numbers, and that's what most of statistics is dealt with. And so for at least this semester, we're not going to spend a lot of time talking about inferential statistics. That's kind of like the next stage after you do descriptive statistics. I'll say a little bit about inferential statistics today. And possibly, if there's interest, if people want this as a topic for the spring, then we can do some inferential statistics in the spring. Okay, inferential statistics is very important anytime you want to do some kind of scientific study, either hard sciences or social sciences. You want to do a study, you want to get some data and infer something else based on that data. So that's inferential statistics. Yeah, so we'll cover some inferential statistics in the spring, even though this goes beyond the high school math curriculum. And let me say, so this semester, you're generally going to be doing what's called univariate statistics. Okay, so it's univariate statistics, which means we're looking only at one variable. A lot of times, if you're designing some kind of study, you're trying to learn something, what you're actually going to be interested in is what's called bivariate statistics. Where you're looking at two variables. I'll say a little bit more about this, but usually, one variable is your independent variable, where you want to, that's kind of the cause. And the other variable is the dependent variable, that's the effect. You want to know how one thing affects another thing, so you have to collect data on both of them together in order to understand how they work together. Okay, but at least for the statistics, that's part of the math curriculum in high schools, that is mostly That is mostly descriptive statistics for a single variable. So that's what we're going to be focusing on now. And if people want to do some more advanced stuff in the spring, we can do that. Okay, good. So before I move on from, well, okay, let me do one more slide, and then I think Charles Brupla is joining. So I'm going to I'm gonna let him introduce himself after I do this. So what are the types of, so why is statistics important? Why should we study statistics, right? Well, there's lots of questions. Basically, almost anytime you want to learn anything quantitative about the world, anytime you want to learn anything quantitative about the world, usually you have to use some statistics to understand whether your questions are good questions, whether your answers are good answers. Who knows? So here are some examples of questions that you can apply statistics to. So how do we know whether a blood pressure drug is effective? Let's say you have a drug that's supposed to reduce your blood pressure. So how do we know whether it's effective? Well, it's, early in the early days of medicine, people just took it. And if they thought they felt better, then it was effective. But, nowadays we know that there's much better ways of measuring something like this, right? So you'd need to maybe have a study, and you'd have to have a number of people enrolled in the study. And ideally, you'd have some people take the actual drug, and you'd have some other people take what's called placebo, meaning just a drug with nothing in it. It looks like a pill, but it's actually just sugar or something. It doesn't do anything. And then you'd want to see if the blood pressure went down more in the people who took the real drug than in the people who took the fake drug, right? So how do you do that? Well, you have to look at a lot of people. You have to see how their blood pressure reduced, and you have to have some sense of what is a meaningful difference between these two things. That's often called statistical significance, okay? But in order to decide what statistical significance is, you have to have some sort of test. So there are various statistical tests that you can apply to this to try to come up with, a real answer, like, is this actually effective? Or maybe the people whose blood pressure went down, it would have gone down anyway without the drug. How do we know? And so statistics can help us answer that question. Okay, so another question, is Earth's climate significantly warming? Right? In order to, this is the general consensus of scientists today, is that yes, the Earth's climate is significantly warming, right? But how do you know that? Well, you can't base it just on how you feel when you walk out. You need data. Climate agencies collect lots and lots of data of temperature at all points on the Earth's surface, and they keep track of it over long periods of time. And you need to be able to do some statistical reasoning on that data to know, is this actually a trend, or is this somehow random noise? Like, it's getting hotter now, but it'll probably just get cooler later. People generally believe that, yes, this is a trend and the Earth's climate is getting significantly warmer, but you need some statistical reasoning in order to really conclude that. Okay. So, by the way, let me say, this would be here an example of kind of bivariate statistics. Because you have kind of two things. You have whether or not people are taking the drug is kind of one of your variables, and how much their blood pressure goes down is another one of the variables. This would be more univariate statistics. Okay, and that's because, you're really only looking at temperature. Okay, that should be maybe enough. We're not asking what affects global warming. That's another question. We can say, does increased burning of coal cause the Earth's climate to warm? Most people think the answer is yes. To answer that question, people have done a bivariate statistical analysis. But if we're just asking, is the climate warming at all, then that is a univariate statistics question. Okay, so another thing, how does obtaining more schooling affect a child's future income? What is the benefit to your income for staying in school one more year? Would this be a univariate problem or a bivariate problem?
Would be a bivariate problem.
Exactly, right? This is a bivariate problem because we have kind of two variables. We have obtaining more schooling. So one piece of data that you need to keep track of is how much schooling does your population have, right? And then your other thing is future income. So you'd need to say, okay, you got this much schooling. Now, 10 years later, what's your income, right? And you could do this at the level of individuals. You can do it at the level of countries or counties within a country, right? We could look at average schooling in different counties and income. And, it's hard to design these studies well and carefully. But in any case, this is a question about bivariate statistics. And then you could ask also, who is the most effective goalkeeper in the English Premier League, right? What does that mean? Well, you have to decide what constitutes effective goalkeeping and how can you have enough data to do that. So you might just say, well, people keep lots of statistics, goals against average and, things like that. But you might be, well, maybe this goalkeeper, people score very few goals against him, but maybe that's just because his team is really good and they're on offense most of the time and he doesn't have to make a lot of saves, right? So maybe you want to use save percentage, or maybe you want to have a whole bunch of different statistics that you somehow combine into some index to try to understand what's going on. So this would usually still be, a univariate problem, because you're not really looking about how something affects something else. You're just trying to understand, what is effective goalkeeping. So, but I should write this over here. This is bivariate. Okay, but in general, sports analysts use lots of statistics, whether it's soccer or basketball or baseball or, track, anything. There's, of course, sports statistics are all over the place. And so people try to find all sorts of statistical measurements to, decide who's a better player. And nowadays, people have very sophisticated statistical tools to try to, guess who's going to be better, and people are using that to determine how aggressively they want to sign a certain player on their team. So in any case, statistics super widely applicable to lots of very different types of questions. I didn't mention politics here, but politics, of course, is a big thing where people are polling politically. There's a lot of statistics that goes into, can you have a political survey? Is it accurate? Can you trust your results from that survey? Okay, so statistics is, again, of just supreme importance anytime you're trying to use data to make any sorts of conclusions about the world. Okay, any questions? Okay, so let me just say quickly, what are the topics that we're going to cover in the fall? So these are topics we will cover in the fall. Okay, so these are the kind of standard school topics that you need for descriptive statistics in order to be able to really do anything. So one very important thing is graphical presentation of data. If you have a lot of data and it's just a bunch of numbers in a list, that's often not very easy to understand. If somebody just hands you a large spreadsheet full of data, it's usually not easy to draw any conclusions from that. So depending on the type of data, there might be different types of ways that are appropriate to present it. So it might be that what's called a frequency table is what's most appropriate. There's something called a frequency curve. You might want a bar chart or a pie chart or a histogram, or sometimes you have maybe I'll say also maybe like a data cloud, something called a best fit line, etc. So there's lots and lots of ways of presenting data, and depending on what kind of data you have, a different way of presenting it might be most appropriate. So percentiles, this is a basic thing. People often don't really understand what a percentile means. So calculating percentiles. A whole bunch of measures of central tendency. So this is kind of, what is the average, essentially. So I mean, a main measure of central tendency is called the mean or the average. You have a whole bunch of different data. And if you want just one number that is kind of should signify what do you expect, what's kind of the most representative number from this data, then you have, various different ideas that you can use for that. And those are all called measures of central tendency. So even more than that, you have something called measures of dispersion, which is, well, is your data very consistent? Does it tend to vary only a small amount? All of your measurements are all pretty close to each other, or is the data all over the place, right? And depending on your problem, you might have very dispersed data, or you might have very, nailed down, non-varying data. Okay. So, and then of course, statistics is based on probability. We're not going to do a deep study of probability, especially since we covered that last year. But, some amount of probability and relative frequency, to the extent that figures into statistics, we'll need to talk about that. Okay, so these are kind of the topics we're going to cover. Maybe I'm not going to say more about any of these, because these topics will all get classes that are devoted to them. But let me talk about a few things that we're not going to really emphasize so much this semester, but that should get a word about them. They deserve to say something about them. So first of all, where does your data come from, right? I mean, in a textbook problem, the data is just handed to you. Here's the data, right? Do something, calculate the average, calculate the standard deviation. But in general, like, how you get this data is important. And if you're reading a newspaper article where they make some kind of statistical claim, something that you're going to want to know is, where did this data come from? Is this reliable? Is it biased? Can I trust, this data? So a standard way to collect data, especially data from people, is that you want to use a survey or a sample, and where you want to try to understand something about the whole population, but you can't interview everybody. You can't ask everybody your questions. So instead, you ask a smaller amount of people, and you hope that the answers that you get are representative, meaning the answers that you get will help you conclude something about, the larger set of people, and maybe you didn't interview everybody. So for instance, suppose that we're a substitute teacher and you're walking into a class and you want to know how well prepared they are. So you ask how everybody, and you want to know how everybody did on the last exam, but there's 50 people in your class and you don't have time to ask everybody. So you look at the 5 people sitting in the front row and you ask them each what their score was. And then you compute the average and you guess that that's about how well everybody in the class did. So can somebody say, what's a potential problem with this method? Why is this maybe not a great way of collecting data? There's more than one right answer. Right, so what might be unreliable about collecting data this way? And you can just unmute yourself and give an answer.
Yes, sir.
Yep. Mm-hmm.
Prince.
Yes, Prince. Hi, welcome.
Yeah. Thank you, sir. I'm seeing what would be the wrong method of using this is maybe it will not be to the tax. It will not be expensive to everybody. Maybe to the person in which the data is need to be collected. So it will not be to that extent where someone have to read and then honestly analyze that type of data. So I think this is a way in which it will be wrong.
Okay, so this is one thing, right? So maybe the average is not enough information. Is that what you're saying? Yeah. Okay, maybe the average is not enough information.
Yes. Also, I want to.
Yeah, Clinton. What else might be wrong?
Yes. Another reason why that is not a good method of collecting data might be the students might not be honest with you to give their exact grade at school.
Sure. Okay. Students, students' reports could be unreliable. This is a problem that people have a lot of times when you're trying to understand, what percentage of people support a certain policy or believe a certain thing. Is that a lot of times, at least in the United States, people will say things that they think sound good to the person doing the survey and might not tell the truth. They might be embarrassed to admit what their real opinion is on something. So pollsters have ways of getting around this to try to really solicit honesty. But anytime that you're asking somebody just for, to tell you something, there's always the possibility that they're not being honest. Anything else that might be wrong with this? So I can think of maybe two more things that might be wrong with this. Well, so depending on how many people are sitting in the front row, maybe there just aren't enough people there to really, the class is too big. Maybe the number of people in the front row is very small, and it's just going to be too small a sample to get anything to get anything reliable about. So maybe the sample size is too small. And then there's one other thing that's very wrong that I think is a problem. So this is specifically the front row. What might, if I'm asking the people sitting in the front row, what might be a problem with that? Yeah. Richard? Sorry, I can't hear you. So what might be wrong? What might happen if I ask the people in the front row? Who sits in the front row of class?
Yes.
Yes, Clinton.
Yeah, so those who sit in the front row of the class are students who want to pay attention. So we can say the smart students.
Right. So what you're saying is that this could be a biased sample, right? You maybe expect the people in the front row, they pay more attention, they're better students, their grades might be higher. So this is maybe, so the word we use in statistics is this could be called a biased sample. And so, for instance, the front row kids, maybe they pay more attention. Okay, so all of this, right? Because of course, there's no right answer here, and it depends on what your class is. How big is the front row? Maybe if the front row, if the seats are assigned randomly, then maybe it is okay to do the front row because people aren't choosing to sit in the front row or in the back row. But just in general, I just take this example just to know that, like, when you take a survey, you have to think about how you're taking a survey. Okay, and you have to think about what you're doing to make the survey kind of useful and representative. And if you don't do things carefully, then there's lots of problems that can come up and that can make your data less reliable. Okay, so any questions about this? Okay, and again, this is not going to be the main focus of the class. This is not what we're going to be doing most of this semester, but I think to talk about statistics and not mention things like this is malpractice, right? And these are things that you have to keep in mind when you do statistics, even if it's not what we're going to focus on right now. Okay, so anybody using statistics for practical purposes in the real world to do experiments, they have to be thinking about this. It's not good enough just to know how to calculate a mean or how to calculate a standard deviation or how to do percentiles, right? You need to also understand what data collection is about. Okay, so all right, so that's data collection. So let me say a word on inferential statistics. So inferential statistics is so again, what I said is when we do statistical analysis, we always have it. It's always on data pulled from real world situations, from something going on in the world. Okay, and inferential statistics is kind of like what I was talking about on the last slide. So it's the process of extrapolating data that's drawn from a sample in order to get information describing a larger group, describing a population. Okay, and so even if your sample is chosen well, so maybe with minimal bias, so not like our front row students example, then you still might have this issue, for instance, of your sample size, right? Maybe have you really interviewed enough people to get a sense of what the whole population thinks? Okay. And so somehow the bigger your sample is, the more pieces of data that you take, then you're generally going to get a more accurate description of your whole population. But of course, a bigger sample also requires, more effort to collect the data. So there are actually, there are quantitative mathematical tools that you can use to kind of measure, how big, if you have some prior belief that, you're trying to get some number and you have some idea of what its mean should be and what its standard deviation should be and all of these statistical things, then there are, statistical equations that you can use to try to say, well, if you interview this many people, then you have this much confidence in your measurements. Okay, so this can be done mathematically, but it's very delicate. So, and this is very big for political polls. Okay, so again, I can only really use the United States as an example. I don't know so much about the internal mechanics of Liberian political polling, but when they want to ask, which presidential candidate is ahead in the polls, so they call up a bunch of people and they want to ask whether they're voting for Joe Biden or Donald Trump. And they they have to know how, and it's hard to get people to pick up the phone and answer. Most people don't want to answer a pollster and tell them who they're voting for, so they have to call lots and lots of people. It's expensive to do a good poll, and so they'll say, this poll, we interviewed 600 people, and this is what the percentages are like. Okay, so 51% support Joe Biden and 45% support Donald Trump, and 6% were undecided, or 3% were undecided. So the question is, right, is 600 people enough that this is actually giving you a sense of what's going on in the country? And of course, one of the problems is, do you have bias? If you interviewed all 600 people in New York City, that might be different than interviewing 600 people from around the country. I mean, even in Liberia, right? If you interview 600 people from Monrovia versus if you're interviewing people from all over the country and all the different counties and rural areas and urban areas, then you may get different results. People have different candidates they'd rather support. And it turns out actually that if you're careful to minimize your bias, you actually can get pretty meaningful results even out of very, very small samples. So even out of something like 600 people, when there's going to be millions of voters, as long as you're very careful about not introducing bias into your samples, then it turns out that you can actually get quite a bit of information out of that. Okay, so inferential statistics is the whole idea of like trying to understand just from looking at a small sample of results, what happens, what can you say about the whole population? And that can be either a kind of univariate thing, like you're just saying, okay, who are you voting for? That's a univariate thing. Here are your candidates. There's kind of only one variable that you're looking at. Or it could be a bivariate thing where you want to understand, let's use the drug response again. So you have a drug, you want to know whether it's effective against some condition. Well, you can't give it to everybody. You have to do a study where you're only looking at a small sample, and you want to know whether that sample, if the effect is big enough in that sample that you can extrapolate that it will have a real effect, on the whole population. Is this an effective drug? Is this something we can market and that it'll work? Okay. All right. Any questions? Okay, so let me just say a little word about bivariate statistics and some problems you can run into there. So I'm just going to review. So what is this bivariate statistics? Well, often when we do a statistical study, we collect data on more than one attribute of a population. And when I say population, that makes you think of people, but population doesn't necessarily mean people. So you could be looking at, a bunch of different cities and trying to collect some data on them, for instance, or you could be looking at a bunch of different schools and trying to collect data on the schools. Like the elements of a population don't need to be people. They can be lots of things. So, for instance, let's say you did a study and you look at various cities and you measure for each city, you know, how many cars are in that city and how much crime happens in that city. Okay. And what might happen is that the data, the cars and the crime seem to be correlated. So there's a mathematical function that you can use, which is called the correlation, which is something that you can compute with two variables. It's a big thing in bivariate statistics. There's something called correlation. There's something called covariance. These are things that you can compute. And it seems like these are correlated. Cities with more cars have more crime. Okay, so you want to say, well, I know our city has a big crime problem, right? And so what we have to do to lower the crime is to burn all the cars, because cities with more cars have more crime. So if we get rid of the cars, we're going to get rid of the crime. Now, this seems like it's a pretty bad policy based on just getting this correlation, right? Because, for instance, you have to have just a little bit of common sense about the situation. And it seems like it's probably unlikely that having a lot of cars is what makes crime happen, right? So what's maybe more likely is that cities with more cars are just bigger cities, right? And bigger cities also have more crime because there's more people there. There's more opportunity to commit a crime, right? So it doesn't seem like if you just get rid of the cars that that's going to get rid of the crime. You still have a big city, and that's maybe at least probably, you know, what's causing things. So what this is called is that there's a third variable that's actually what's behind the correlation. So, you know, probably this is all just common sense, but probably cars don't cause crime. But bigger cities have more cars and more crime. Rufus, is that a question, or you just have your hand up? So this is one of the things that you have to be careful about with statistics, right? Just because if you're doing bivariate statistics, you're analyzing two things and it seems like they're correlated. It seems that if you have more than one, then you also have more of the other. Well, you can't necessarily conclude that one of them causes the other one, right? So there could be just some third underlying variable that's causing everything, or what there could be is, in fact, the correlation could go in the other way, right? So this is maybe another issue. I'll give it a blue bullet point over here. So I'll say, so in general, a correlation is not enough information to determine what's called causation. Let me write this out of it. To determine, running out of space, to determine causation. Okay, just because two things are correlated doesn't necessarily mean that one causes the other. Doesn't mean that the causation, it doesn't, they could be unrelated even if they're correlated, or at the very least, you don't know which one causes the other one. So there are ways to design statistical studies if you're trying to really isolate a causation. You really believe that something causes something else, and you want to understand if that's actually true. You want to verify that. And one thing that you can do is if you can make little changes in the one variable, the one that you think is causing things, while keeping everything else constant, and if you see that making little changes in one leads to little changes in the other, if you can control that, then that might be very strong evidence for causation, that, you know, whatever your level of one variable is actually going to have an effect on the other one. But in general, just because you see a correlation doesn't mean that you have causation in either direction. It means that maybe there could be causation and you need to design a better study to see if you can isolate this causation. Okay, so again, these are not things that we're going to be spending a lot of time talking about in the class. We're going to be doing more math and calculations and things like that. But these are kind of the important things to keep in mind to make sure that when you hear statistical arguments, when you see somebody make statistical arguments to you, that they're being honest, or that there aren't problems with their studies, that their data is reliable. Somebody says more of this led to more of this. You need to ask yourself, is that really what happened? I mean, they can show a correlation, but that doesn't necessarily mean that one thing caused another thing. Okay, so if we talk about bivariate statistics next semester, maybe we'll even do a little bit of it this semester, just bivariate descriptive statistics, where we'll talk about covariance and correlation. I think maybe that might be worth doing. So maybe we'll do a little bit of covariance and correlation this semester, because that's pretty important, and it's something that you can do with standard high school mathematics. Okay, so that's kind of just the overview of statistics that I wanted to do today. So, starting next week, we'll get some real numbers and some data. It'll be more of a math class, but I think I wanted to do like a little overview of, what statistics is all about. So I guess Charles is no longer here. So none of the organizers are here. So let me just, since we have a little bit of time left, let me just say, so we have, some other organizers. So Sange Freeman, who you all know, she's right now in the US attending a conference, but I think she'll be back in Liberia in a week and a half. So she's usually going to be doing the data distribution. And then there's Charles Bropla. Okay, so there, and then also to some extent, Abraham Jabate. Okay, so they're all on the WhatsApp chat. And so they can answer all practical questions. All practical questions, data distribution, etc. And now I guess also, just since we have a little bit of time left, maybe everybody can just introduce themselves. So let me get the view to what do I want? A standard view with everybody. And so maybe everybody can just say who you are, where you're from, what school you teach at. I think a lot of you know each other. You've been in the class for a long time, but it would be nice to just have everybody be able to introduce themselves on the first day. So I'll do the ordering. And if your microphone is not good or you think it's too noisy, you can always introduce yourself in the chat first. So maybe Gabriel first.
Okay. My name is Gabriel G. Ketu Jr. I teach at Chile Labo.
Okay. Good. And so Clinton. You there? Let's skip you for now. William Bondola. I think if you're on mute, you have to turn the mute off, otherwise we can't hear you. Okay, not there. Rufus. So we'll see. I know maybe this is not going to work so well, but at least a few people who can turn their hello, yes.
Yeah, I'm William Bonduro.
Oh, hi. Sorry. Yeah. Now, can you just repeat yourself?
I said I am William Bonduro, mathematics instructor, Kansas in my country.
Okay, great. Christopher.
My name is Christopher, and I do teach at William V.S. Studman High School.
Okay.
Wow.
Big school, right?
What street is it? 12th Street, eh?
So Kaifala?
Yeah, Kafala B. Traore, principal and math instructor at Kafala Islamic Foundation School, Ghana, Monrovia.
Welcome. Marcus?
You know me?
Yeah, I'm
Marcus, the youth editor. I'm now in Rwanda for study, and I'm doing mathematics as well. So this is my third semester for now. The first time I attended the program is second, and this is my third semester. Thank you.
All right, welcome. Dayton?
Yeah.
Oh, so sorry, Charles. Oh, so is this you, Charles? This Infinix Smart 6 Plus, is that you?
This Clinton.
Yes, it's mine.
Oh, hi. Okay. Maybe, yeah. Do you want to introduce yourself now?
Yeah, okay. Thank you so much. I'm Charles Tiabrople. I'm the math coordinator for this program. I work for the Ministry of Education, Division of STEM Education.
Okay. Great. Yeah. So thank you for Charles. Did a lot of organizing for the WITS math competition back in May, and is and helps out a lot with this program also. So glad to have you here. Clinton.
Yeah, sure. Okay, so I want to say thank you to Help Liberia for this wonderful program. My name is Clinton T. Kui. I am the dues of the University of Liberia 110 graduating class, graduated with a Bachelor of Science degree in Mathematics and Physics on May 30th of this year, and I am currently an instructor of mathematics at the Multi International School System, and I also teach Calculus 1 and Calculus 2 here at the University of Liberian.
Okay, great. Thank you. Welcome, Clinton. Emmanuel. Okay. All right. Oh, that sounds good. Okay, welcome. Harris Mulba.
Okay, I'm Harris.
Thank you. You're muted again.
Liberian supporters of the CDC are in the market.
Yes.
They're not calling.
I was part of that.
Some of them do not have food. People who are calling are real people who call on the radio.
Sorry, I'm getting a little bit of background noise. Armstrong. Zawalo. We'll come back to you. Daniel Gray. Okay, we'll come back to you also. Richard, J. Richard. I think a lot of people having bad network today. Harrison Fawn.
A good afternoon and good day to everyone.
Is that Harrison?
How you doing? I want to say thank you very much for this unique platform. This is my first semester. This is my first time participating. I am a mathematics instructor at the Asian Field Institute, Montserrat County, and I'm also studying at the University of Liberia in secondary education with emphasis in mathematics and physics.
All right, welcome to the class. It's good to have somebody. It's good to have somebody new.
Thank you very much.
You're welcome. Lutch Howard.
Yes, thank you very much, Dr. Obus. This is my second time being part of the class. I much appreciate you for the level of education you are imparting to us. I was part of the first class, and the second cycle, I was not because I was out of Andrew, but then I'm back. I'm teaching at the School of Crown System located in Garnersville, Montserrat County. Thank you.
All right, welcome.
Yeah.
Okay. Richard Pade. No, Richard, okay. And Tony Sabia.
Hello.
Hello.
Tony?
Yeah, Tony.
Are you? Yeah. Hello.
Yeah, hello. You want to just introduce yourself?
Yes, I'm Tony Sabia, and I'm a math teacher. I'm teaching 2 schools in Ganta, Nema County. I'm teaching the Covenant Mission School from 7th grade to 9th grade, and I'm also teaching the government school in the same Ganta city from 3rd grade to 6th grade. This is my 2nd time on this Help Liberia program as a math teacher.
All right, welcome. Okay, so I think that's anybody that I missed who needs to introduce themselves? Okay. Good. Okay, so if that's it, then I guess we're basically done for today. Yeah. So we've got, as long as anybody who hasn't written their name into the chat yet, if you did it once, that's fine. You don't need to do it again. But if you've not written your name into the chat, please write it down one more time so that we'll have the attendance for today. And then reminder that the next meeting is September 22nd, so not September 15th. I'm writing that into the chat. So the next meeting will be September 22nd. Let me stop the recording.